H2O right there. I combine it. Plus MnO4 minus yields MnO2 plus 2 H2O 4OH minus. All right, now you can go about this any way you want. I'm just going to hold it for now, but I want you to see if you wanted to at this point, do you see you could eliminate 2 of these H2Os and 2 of those, right? I'm not going to do it right now. I'll just do it at the end when I eliminate my electrons, but you can do it at any time. So if you saw it right now, you saw 2 of the same thing on each side, you can just go ahead and throw it out. But I'll keep it in there so that when I get the electrons equal and I get rid of them, I'll do all the elimination at the same time. So we ran into this situation again. What are we taking these two? 6. Okay. So I'm going to take this one times what? 2 times. So this is going to be 6 electrons plus 8 H2O plus 2 MnO4 minus yields 2 MnO2 plus 4 H2O plus 8 OH minus. And what am I going to do this guy over here? 3 times. So it's going to become, again, I'm going to like to line up my yield zeros so I keep everything straight. So I'm going to have 6I negative plus 3I2, or yielding 3I2 plus 6 electrons. I'm going to add everything up.
Did you times that by 2?
I timed this by 3 to get this to 6, and I multiplied this by 2 to get this to 6. Electron exchange has to be the same. Okay, so when it comes to elimination here, your electrons should go away just as before. The electrons went away. But also, too, we can lose all of these waters there, leaving 4 waters there. And more things may cancel too. So you just be careful that you look. Sometimes OHs will be on both sides. Because if OH popped up in this equation, you might have OHs on both sides to cancel. And so what am I left with? I'm left with nothing here. 4 H2O, 2 MnO4, minus 6I negative, yielding 2 MnO2, plus 8OH minus, plus 3I2. And of course, you should check your work. So what do I have? 8 H's, 8 H's. I got 4 O's here, plus 8 more O's there. So I got 12 on this side. I've got 4 here, 4 O's, plus 8 more O's. 2 manganese. 2 manganese. I already counted the O's. 6 I's. 6 I's, 3 times 2. And then check my charge. I got 2 negatives plus 6 more negatives. So that's negative 8. And I have OH negative 8 of them. That's balanced then. So really, do you see it's not like a big stretch over what you already did? It's just wherever you get to the H plus step, you got to realize that it's acidic, can't have H pluses. But we're going to put them in there because we can fix that problem really easy by adding OHs to both sides. Yep.
So you can only cancel things if they have the same charge?
You can only cancel things if they're exactly the same on both sides of the equation. Okay. So now, although this is not exactly the same, 4 of them are exactly the same.
Yeah. Okay.
Yep.
Why in the oxidation part, why did you add 2 electrons instead of 1?
Because there's 2 minuses, 2 negatives.
Oh, okay.
So I need 2 negatives to balance. Good here? Okay. Yep.
For the last step, the
Yep.
spectators,
Yep.
would they have to be the exact same as the original equation?
How do you mean?
Like when we get the answer at the bottom,
Yeah.
would to eliminate spectators, would they have to be the exact same as the original equation?
No, because I mean, there's the original equation. There was no water in it to begin with.
Alright,
Is that answering what you're saying?
yeah.
Because I'm not sure if I'm following, but I mean, if that's what you're asking, no, it doesn't have to be. It just has to be something that appears on both sides.
Alright, alright.
So like if I had, say, Na plus and Na, I can't cancel those. But if I have Na plus and Na plus, I can cancel those. Good. What do you think we do one single problem, which we'll finish real quick, and then I can be lazy and crack papers and you can take a break? Because to be quite honest, your test is not until Friday. We have 2 full days of review next week. I mean, it's not going to take that long to get ready. Do you think? I mean, just wondering. I just don't see the sense in drilling all these problems right today. We're not test until Friday when we can gear up on the week.
All the review homework's the same as this, right?
Yeah.
Okay.
Okay, so let's do one problem. We'll get you guys to come up here. So I'm just going to go to, this wasn't from yesterday. Yesterday you had D and E. This is from the day before. This is C, 74C. Okay, yeah, this is an interesting one. This is a good one to go through. We'll see how you guys handle this. So solid lead, Pb, plus Pb, I think it's O2, yields, or plus H2SO4. Yields PbSO4. Okay, so this one's going to look a little different, but we'll see how we handle it.
This is acidic, right?
This is acidic, yeah, I should probably put that up there for you, 'cause now it's becoming an issue. So we're not going to do any of that OH business, right? All right, so let's see what happens here. Okay, so just like before, how about first guy that comes up does the oxidation state of the reactants, so they got more to do. The second guy does oxidation states of the products. So first guy up will be Ching, Adam Upperman for the reactants, Garrett Height for the products. So I see you're an avid dodgeball superstar. That's what you wrote on your sheet.
Oh, yeah. I don't remember writing that. That was a long time ago.
I love seeing the things.
Have you ever seen anything bad? There's a periodic table.
No, not really, no. One of my guys last year goes, not last year, I'm talking years ago. Do you remember Jermaine Easter? Yeah, he is, yeah, Jermaine. Jermaine put on his thing, WRASLIN apostrophe.
Wrestling?
Wrestling. Wrestling. Tricky stuff comes up in this one. Both. Okay, so this might help these guys that are up here. Bo just said, do you use the charge of SO4 or you just go with O being -2? And I said both. SO4 is -2, isn't it? Okay, and each O is, in terms of oxidation state, -2. So if you have 4 -2s, that adds up to -8. And SO4 is going to add up to -2. So that means S must be +6. And that means if SO4 is -2, then PB must be plus 2, and then each h by rule needs to be plus 1. You see how I can break that apart into the ion and get the, if we don't get that, we're going to look at that real quick here. So let's say we got this one here. We got what, PbSO4, and we have H2SO4. What I was saying is that this thing here is actually SO4 minus 2, and this is H plus and H plus. So that means that this is negative 2, and that means this must be plus 6. Plus 6 minus 8 is negative 2. Well, this one here, we have SO4. Oh man, I thought I was feeling it too. So much for that.
Why don't we include H into the...
What's that?
Why don't we include H into the total count? Like in the H, SO4.
We do.
It gets lost in the water, I think.
There's 2 H's.
But into
No,
the
in
negative
products.
2. Like in the...
We did. Because there's 2 positives and there's 2 negatives.
No, he's asking why it doesn't go over to the product. Does it just turn into
I told you
water?
that. I told you yesterday that kind of stuff happens.
Yeah.
You just got to go through the process of balancing, and you'll work that out.
I was saying-
But that's not what he's asking.
I was saying like, because it's negative 8 plus 6, which is 2, but then why?
That's
don't-
negative 2, right?
Yeah, but then.
That's
why
plus
don't
and plus.
Then that would be
0. Yeah. Yeah. And so this same thing, right? This is negative 2. So this, each O is negative 2. You got 4 of them, so that's negative 8. So this is plus 6. That all adds up to negative 2. So this PB must be plus 2.
makes sense.
You following that? So here I'm showing the charge on the whole SO4. Here I'm showing you the oxidation states of each individual one. Okay. All right. So let's see. Let's say Jarrell gets an F for the day. Oops. Oh, sorry. It slipped. Wake up, Jarrell. You awake? You awake, Jarrell? Get up. Do you know what they used to do when I was here?
Check marks at your eyes.
They used to do a gravity test. And so they go up to you while you're sleeping. They say, see, did gravity still work? Yep. But they wouldn't drop it on the ground. They drop it someplace else. Just to test gravity. All in the interest of science. Okay, Peter Fusina, let's connect our oxidation state, and Ronnie, connect our reduction. So don't overcomplicate it. Just take things that are being oxidized and connect them, and things that are being reduced and connect them. You're going to find out that this is going to look a little different.
So, since we just broke up the S and the O's from SO4, they wouldn't be polyatomic ion now when we're like we wouldn't consider them polyatomic ion when we're identifying which is oxidative, which is.
Wait. You got a lot of room you're wasting. Oxidation state, we just consider each element. There you go. Okay, so you're going to say, what's going on there?
Yes.
Reduction, okay.
Wouldn't you connect this with that too?
Nope, because they got to connect opposite sides. That's a good question. I've not heard that question. That makes sense. So that's going to go to one.
I went short for 3 years.
That's
crazy.
Calvin has it and Rod has it.
I've started out.
That's not wrong.
I was not changing that. I was negative 2 throughout the problem.